Every time you tap a link, something begins. It happens instantly. It happens silently. But it is not simple. Your device wakes up. Your browser prepares a request. Your operating system starts building the data. Deep below the surface, a layered machine comes alive. This machine is the network stack. It is the system that moves your data from your device to the world. Most people never think about it. They never wonder how a message crosses oceans. They never wonder how a video loads in seconds. They never wonder how a website appears almost instantly. Today, we slow everything down. We peel back the layers. We watch the internet breathe. From Ethernet to IP to TCP to HTTP. This is how the internet moves. Before data becomes a packet, it becomes a signal. A signal can be electricity. It can be light. It can be a radio wave. Ethernet controls this physical world. It defines how devices identify each other. It defines how frames are shaped. It defines how collisions are avoided. Imagine a warehouse filled with conveyor belts. Each belt carries a sealed box. Each box is an Ethernet frame. Each box has a source address and a destination address. Ethernet does not care what is inside the box. It only cares about moving the box to the next device. Switches read the labels. They learn which devices live on which ports. They forward frames quickly and efficiently. This is the foundation of the internet. It is the physical heartbeat of everything we do online. Ethernet is local. It works only inside a building or a small network. To travel across the world, data needs global addressing. It needs a way to identify any device, anywhere. That system is IP, the Internet Protocol. IP gives every device an address. It is like a home on a global map. An IP packet is a traveler. It knows its destination, but it does not know the route. Routers decide the route. They read the destination address. They check their routing tables. They choose the next hop. IP is powerful, but it is not perfect. It does not guarantee delivery. It does not guarantee order. It does not guarantee reliability. It simply moves forward, hop by hop, doing its best. Now we enter the world of structure, the world where order matters. TCP is the protocol that brings reliability, ensures that every packet arrives, ensures that packets arrive once, ensures that packets arrive in order. It ensures that the sender does not overwhelm the receiver. TCP begins with a handshake. SYN, SYNACK, ACK. This handshake creates trust. It creates a connection. Then TCP assigns numbers to every segment. It waits for acknowledgements. It retransmits anything that gets lost. It adjusts its speed based on congestion. If the network slows down, TCP slows down. If the network opens up, TCP speeds up. TCP is always adapting, always negotiating, always protecting the flow of data. If IP is a traveler, TCP is the architect who builds a safe road. Not every message needs perfection. Some messages need speed. Some messages need immediacy. This is where UDP lives. UDP is simple. No handshake. No acknowledgements. No retransmissions. It sends data without waiting. It sends data without checking. UDP is fast. UDP is lightweight. UDP is perfect for gaming, voice calls, and live streams. It is the motorcycle courier of the internet. Fast, agile, willing to take risks. Every device runs many services at the same time. Web servers, DNS resolvers, streaming apps, background processes. Ports are the doors to these services. Port 80 for HTTP. Port 443 for HTTPS. Port 53 for DNS. When a packet arrives, the operating system checks the port number. It uses the port to decide which application should receive the data. Without ports, nothing would be organized. Every message would arrive everywhere. Nothing would make sense. Ports bring structure. They allow thousands of conversations to happen at once. At the top of the stack sits HTTP. It is the protocol humans interact with every day. HTTP is simple. A client asks for something. A server responds. Get 200 OK. But behind this simple pattern is a large system. Headers, caching rules, cookies, compression, content negotiation. HTTP turns raw data into meaning. It turns packets into pages. It turns requests into experiences. It is the language of the web. The modern web needs more than communication. It needs security. HTTPS wraps HTTP inside TLS. TLS encrypts every byte. TLS authenticates the server. TLS protects the user, ensures that no one can read your data, ensures that no one can modify your data, ensures that no one can impersonate the server. HTTPS is the armor of the internet. It protects every login, every purchase, every private moment. Now we put everything together. You click a link. Your browser creates an HTTP request. HTTP hands the request to TCP. TCP breaks it into segments. IP wraps the segments into packets. Ethernet carries the packets across the physical world. Routers forward them. Switches deliver them. Servers receive them. Then the entire process reverses. The response travels back to you. All of this happens in milliseconds, billions of times per second, across the entire planet. The network stack is not just a design. It is a living system. Ethernet moves the signals. IP moves the packets. TCP shapes the flow. HTTP gives it meaning. Together, they form the foundation of the modern world. Every message, every stream, every connection, every moment online, all of it depends on this layered system, a system we rarely see, but rely on every second. Thanks for watching, and I'll see you in the next chapter of this digital adventure.